Okay, in this optics lesson, we'll be talking about the reflection of light and mirror images. So these are the learner's outcome. Okay, when light strikes a surface, it is found that it will bounce off the surface. And it is actually similar that if you throw a tennis ball on the floor and it will just bounce off. And it is observed that both light and the ball bounce off the surface in a similar manner. And this bouncing effect of the light is known as the reflection of light. So for light that strikes the surface, we term it as incident ray, and the light that bounces off the surface, we name it as the reflected ray. So let's look at a particular video and see how the reflection of light looks like. Okay, so you can see that right now this is the light ray that strikes a particular mirror and then it bounces off. So this is known as the reflection of light. Let's look at how when you change the light, how it will bounce. So as you can see, the light source is at a different angle, or strikes the surface at a different angle, and you notice that the reflected ray also behaves in a certain manner. So this is known as the reflection of light. Okay, let's look at the terms of the reflection, okay, so that we have a common understanding. So first of all, the surface, and when the light strikes is known as the incident ray, and the light bounce off the surface is known as the reflected ray. Okay, one important line that I'm going to show you next is the normal line. Okay, this normal line means that the line is 90 degrees to the surface. So this is an imaginary line. Okay, later we'll highlight why is this line important. Then this is known as the angle of incidence. Okay, the angle of incidence is actually starting measure from the normal line. We treat normal line as the 0 degrees, and the angle of incidence I is known as this particular angle from normal to the incident ray. So likewise, angle of reflection is from the normal. You start from normal at 0 and you measure this. So this is the angle of reflection R. As observed, okay, it was found that the angle of reflection and of light is equal to the angle of incidence of the light. So this is known as the law of reflection. Angle of incidence is equal to the angle of reflection. And actually this feature of light will actually help us to understand the following concepts. Why is it that you can see yourself in a smooth mirror but not on a white wall? And how do plane mirrors or mirror form an image of an object? Okay, so one of the question, okay, which of the following materials can the law of reflection be applied on? Okay, is it mirror, paper, water surface, rough rock, glass surface, white wall? Okay, take some time to think about it. Okay, one particular misconception about light reflection is that only laws of reflection only applies to very reflective surface. So which means that mirror or water surface or glass surface, only laws of reflection actually applies to them. Okay, where paper, rock, and laws of reflection don't apply to them. But that is not true. Okay, in fact, okay, this is not true. In fact, all of them actually, the laws of reflection actually applies to them. Okay, but why is it that then mirror, water surface, and glass surface actually reflects light, or you can see an image within the surface? Okay, the reason is very simple. Okay, because the surface is very, very smooth. Okay, so this specular reflection means that the light ray as it strikes, okay, as it strikes, every of the light ray behaves in a similar manner where the surface is very smooth. Okay, so the loss of angle of incidence is equal to angle of reflection uniformly. But you find that for rough surface such as rock, paper, or even just a white wall or a surface that similarly is smooth but actually they are pretty rough, you find that the light ray actually, once they get a bounce off the surface, they bounce off everywhere. So there's no coherent light ray that actually comes unlike this smooth surface. Okay, let's take a zoom in picture. Okay, a large picture of the diffuse reflection. So what we meant that For rough surface, the law of reflection still apply is because you find that for A, the light ray strikes this particular surface. If you draw the normal for this surface, you find that the angle of incidence is still equals to angle of reflection. But for B, you find that as it strikes a rough surface, the surface is actually different from where it strikes A. So in this case, it bounces off differently, but still angle of incidence at B is equals to angle of reflection at B. So it's still the same. So you find that for C, okay, in this case, the angle of incidence and the angle of reflection is the same, but of course it strikes off another rough surface and it bounces off according to angle laws of reflection. So all the light rays A, B, C, D, E, when it strikes a rough surface, the angle of incidence are different. So that's why the refraction angle for the surface is also different. But individual rays do behave for the law of reflection. So for mirror image, the word mirror image suggests that the image formed by a mirror is exactly the same as object. Okay, as you can see from this cute cat photo. From your daily experience, the image is appearing in the mirror. So if this is the object, this is where the image would be. Okay, it appears inside the mirror. And it looks almost exactly the same as the object. So how do mirror actually forms the image of an object through the reflection of light? Okay, so you see this image of the cat is actually because there's some reflection of light from the cat to the mirror, and then it bounces off and you see the image. Okay, so let's look at this. So a light ray would actually form, okay, and strikes the mirror, and then it will bounces off, and the light ray actually seems to come from in the mirror, and this is where the image location would be. Okay, let's look at it. Okay, let's zoom in. Okay, let's zoom in and have a look. So you see that all the light rays over here that is coming out from the light bulb, okay, strikes the mirror, and each individual light rays actually behaves by the law of the reflection. Okay, so the light ray actually bounces off in this manner, and when you let it move on again, so right now the light ray seems to come from this location. Okay, remember the light ray actually comes and then it bounces off, and the light ray seems to come from this location, and this is where the image is located. So, and that's how we see the image formed by the mirror. Okay, so this is another illustration. So you have the object that's over here, you have the eye that's over here, and how do we see the image of the object inside the mirror? So the light ray strikes the object, okay, from the object reach the mirror, and it will bounces off according to the laws of reflection. Okay, so you find that if you draw a normal line that's over here, the angle of incidence will be equals to the angle of reflection. Okay, so let's trace another path. So if you have a second light ray, same thing, this yellow light ray would also follow the same idea, except that right now the angle of incidence is slightly different, and the angle of reflection would be the same as this new angle of incidence, so it will reach the eye. Okay, our brain doesn't know that the light ray has been reflected, but it thinks that the ray has traveled in a straight line and come from within the mirror. So if we extend the blue and the yellow line through a dotted line, you find that the light ray seems to come from here, and this is where the image would lie. Okay, these two lines are dotted because they are imaginary and doesn't actually exist. So actually no light ray actually comes from behind the mirror. So where these 2 points are intersects, okay, or these 2 dotted lines are intersect, is where the image of the object will be. So this is how we see that there's an image of the object inside the mirror. but actually, of course, there is no real light traveling from inside the mirror out. The actual light ray is from the object, bounces off the mirror, and then reach the eye. But we have this illusion that there's this image inside. And this illusion is known, or this kind of image is known as the virtual image. It's virtual. So characteristics of image formed in a plane mirror. Okay, so this is simulation. You find that this is the picture that we have shown you just before, the object, and then this is the eye. And one thing about characteristics of the image is that no matter where you move the eye, you find that the image would always be the same position, meaning that it is the same, over here. Okay, even if you shift the position of the eye. Okay, if you shift the position of the eye. Only when you shift the position of the image, the object, then you find that your image moves. Okay, but you realize that the angle of incidence is always equals to the angle of reflection. And of course, I can show you what we actually showed you just now. So what are the characteristics of a mirror image? You find that first thing is virtual, meaning that there's actually no actual light ray that's coming out of the mirror. Okay, it is upright. It is the same size as the object. So that's why you seem to see that the mirror image is exactly the same as what the object is. It is laterally inverted. We'll talk about that later. Okay, and one very important thing is that the image distance is actually the same as object distance along the normal line for the mirror. And what it simply means is that when the object is far away from the mirror, the image will appear to be far away. And when the object is close to the mirror, the image appears close by. So this one will both describe this idea and the laterally inverted. Okay, so even if you have a simulation of an image of a large object, this is what is going to happen. So instead of one single object, you'll find that if you have a large object such as this, is like a rod, you find that the image would also be similar to what is in the object. So you realize that the distance over here is shorter, and the distance over here is further. But you find that it's actually the image distance will always be equals to the object distance. Okay, so that's all for today's lesson.